Hello everyone, my name is Viraj and today we'll be looking at the 16th problem from the CP-31 sheet by TLE Eliminators under the 900 rated questions. Let's go. So moved on to my CP-31 sheet, ticked off 900 rated parameter and the problem Deletive Editing. Alright, so let's read this. Daisy loves playing games with words. Recently she has been playing the following Deletive Editing word game with Daniel. She picks up a word, for example, determined, and then each turn Daniel calls out a letter, for example, the letter E, and then Daisy will remove the first occurrence of this letter from the word, getting the word that is D, and then because E is removed, so DTER, mint. On the next turn, Daniel may call out some other letter, let's say D, and then the same thing happens. They continue with I and N and so. And now if Daniel calls out E, Daisy gets to the final word that is TRME, but then there is no way that she could get to TERM if they start playing the word determined. So they have given you a simulation of the process. We'll actually discuss this, how that's happening. Now, Daisy is curious if she can get a final word of her choice starting from the initial word by playing this game for 0 or more number of turns. Your help is to figure this task out. So you have been given this string S, that is your initial string where you start off with, and the string T where you actually want to land, which is the final string you want to create. Okay, great. Let us try to generalize this problem and simply understand. Again, it's a very, very simple problem. You start off with a string S. So I'll have the letters in this. Let's say the letters are S1, S2, S3, so on. And then let's say this is an N-sized string. So you can say last letter is, let's say SN. So what happens is these are some letters. So they have actually given you an example. Let's say the example is DETER, mint, determined. So what happens is basically a game is being played where I, as a person, or maybe the guy that's Daniel in the question, you can say Daniel calls out a random letter from A to Z alphabets. And when I call out that letter, when Daniel calls out a letter, I look to remove the first occurrence of that letter in my current word. So let's say I have called out the letter E, then from the left, the first occurrence of E is at this location. So I'll just say that, okay, this letter has totally been removed from my string now. And this string has now become like this. It doesn't look like determined. It looks like something like determined, something like that, because that E is gone. Next time, if I simulate this further and I say, okay, some more letters are called, let's say the letter is D called, then I called, N called, and so on. So it happens that, okay, some more letters are removed. Let's say R was called, for example. So I'll remove R, that's the first occurrence. Let's say then M was called, again, remove first occurrence, M, so on. Let's say now E is again called, then I'll remove the first occurrence of E now. That is, from the left, I can say there are two E's right now in this whole string, but I would prefer to remove the leftmost E. So this is this E, remove this again, and so on. So the string tries to modify itself, and finally you can say you stop somewhere, right? There is some stoppage point where you say, okay, I have some string, which is now, I have some sort of final string, you can say, which has been done after doing some sort of operation, some moves that have been done by this. And then what's the question? The question is, initially, even before starting with the question, you will be given a string T. And the question is, do you think that in some number of operations, you can actually make this final string look like the string T? If you can actually do that, then you will say a yes, else you will say a no. So this is just like a yes-no based question. Okay, let's actually take some sample case. So I think we'll better understand that. So let's say I'll just take up maybe I'll take up the first case only. So that would be much better. So let's say I have this string S that starts with determined. And then I have the string T that is basically starting with, is basically TRME. So, okay, so T, R, M, and E. So now what will happen is, just like I'll give you a small set of moves that I might simulate. I'm not going to do them exactly, just a small simulation. Let's say I tell you to remove the first D. So I'll say, okay, remove D, then also remove D. So you will remove this D first. That is the first occurrence of D. Now when this D is gone, what's the next first occurrence of D? Of course, this D. Okay, great, gone. Now let's say I'll tell you to remove the first E and then one more first E. So you will remove this E first because this is the first occurrence of E. Then this E first because this is the next first occurrence of E when the string would have modified. Great. Now let's say I would have told you, okay, remove the first I that is there. So you'll remove, okay, any I is there, yeah, you can see an I, great, removed it. Then let's say I want you to remove the first N in the string. So you'll remove this N. Now I have performed these 6 operations. You can call them by saying, I would have called them out like remove the first D, remove the first D, remove the first E, E, I, and N. Now if you observe string S, it has actually converted to T, R, M, and E. And don't you think this is actually string T? Yes, this is string T. So can I say that some finite set of moves I did that were exactly these 6 moves, and yes, I actually received the string T that I wanted. So can the answer be yes? Of course the answer can be yes. Had I not been able to do that in some finite number of moves, I would have said the answer is no. And this is actually the simulation of the first case. Now, based on this, you can pick up your pen and paper, maybe run a quick simulation in your head or through a pen and paper of the other 5 cases. Maybe try to get some idea of why do you think the answer is yes over here and why do you think the answer is no. And things are going to look much more clearer with regards to the problem. Okay, great. I hope this is clear. I hope the problem has been generalized. All we are trying to do is a small simulation, and I hope the test cases are generalized. Okay, so now let's move on to how and what sort of a time complexity is expected in this problem, which is very, very important because that is going to help us form some ideas in our head even before we start coding. So I know that 1 second basically allows me 10 power 8 elementary operations. And then it's given over here that time limit per test is 3 seconds. So basically that says that, okay, one test is allowing you 3 seconds. So that means 3 into 10 power 8 elementary operations is something that's allowed to you for every test. Now, for every test, actually, there are some number of test cases. Now, I think in this problem, they have taken that variable as n because you had already a variable t that marked in the string, so don't confuse that. You have some number of test cases that are actually in 10 power 4 order, which means if I want to ask you what's the number of operations you can actually perform for every test case, then that would be 3 into 10 raised to 8 upon 10 raised to 4, which means 3 into 10 raised to 4. Now this is very, very important because now if I look at the strings, that is the string S and T, you can say each word consists of at least 1 and at most 30 uppercase English letters, which means that S and T both are in maximum 30 order in terms of their length, correct? Now if that is the case, I can just note this down. Let's say the size of S was something like let's say the size of that S is S, then you can say that this is in 30 order and T string also is in 30 order. Okay, so let's just say that I am creating a solution that is dependent in this 30 order sort of a solution. Then do you think I can for 10 power 4 create a solution that runs somewhat in like S cube, something like S cube, right? Can I create something like S cube? Yes, I can, because S cube means I'll be creating something like 30 cube. And 30 cube approximately is like, this is 3 into 3 into 3. So that is basically 27. And then you have 0, 0, 0. So you have basically 27,000 operations. And that is definitely lower than 3 into 10 raised to 4. I think if we exceed this range and we create something like 8, 1, 0, 0, 0, 0, that is like S power 4, then things are going to be a bit tedious for us, because that is where we start crossing the boundary. So somewhat like an S cube solution is fine to work with, right? And in terms of, again, I'm talking about in terms of when we are talking about 30, it might not be necessary that the solution runs in the complexity where the dependent factor is S or maybe even T, maybe it can be some combination, but we are all trying to understand is what sort of an order are we trying to limit ourselves to. So if S cube works, then of course S square works, O of S will work, so on, so on, so on. If you're able to create a constant solution, that's all good to go. But anything above this is a problem. So this creates an upper bound for me. And this gives me a hint that, okay, make solutions like this, assuming your logic is right, but don't go beside that boundary. And this is my expected time complexity discussion. Now, this is very important because now I know that I have a very good range on what I can create my solution to be. Maybe I don't actually create a solution that runs in such a cubic order. Maybe I create something that runs in much lower than that. But even if I go in that limit, it's fine. So if I would have attempted this problem in a consume space, then I know I am good to go to create solutions that might go in cubic order. Okay, great. So this is the expected time complexity discussion. Now let's try to actually think in this problem. Now, since we are understanding that this problem is allowing you to have a very brute sort of a solution, since you have such a high range of time complexity allowed, that means somewhere or the other, I can understand this is a simulative based problem. And from the simulation, if I'm able to pick up some minute observations, maybe I can just boil that simulation out and I can directly come to a conclusion which will help me finally solve this problem. So I'll have a very small observation in this problem. That is, let's say you have the string T. Sorry, the string S to start with, that is the S1 letter, S2 letter, so on, so on, so on, S3 letter. And then you have the string T, that is the T1 letter, T2 letter, and so on, so on, so on, so on. Correct? Now, let's say I'll talk about this very simple case. Let's say I'm talking about the letter A. So the letter A will have some occurrences in the string S. So that will be, let's say, frequency S, Fs. And similarly, this letter A is going to have some occurrences in the string T, that is Ft. So now let's say there are 3 occurrences and let's say there are 5 occurrences over here. Let's just say that there are 3 occurrences in the string T and 5 occurrences of A in the string S. That basically means that you want 3 A's to remain after you have removed 2 A's from the string S, because in the string S you basically have 5 A's, that is more, correct? Similarly, if I would have taken some other letter, I have an independency to calculate the answer in terms of that whole idea. When I talk about, let's say, the letter B or C or D, the idea there will be independent. So right now, if I can focus my energy on A and if I can bring some conclusive proof to some letter like A, that same idea can be copied to other letters also and can be generalized throughout for each and every letter. For B, for C, for D, so on till the very last letter, that is capital Z. Okay, so now I can generalize an idea first starting with A. The idea can be, let's say you have the frequency as 5 and let's say the frequency is 3. Then over here I can imagine, okay, I would have removed 2 letters from the string S. Great, makes sense. But what would have happened if you would have started off by saying there were actually 2 letters only in the string S? Then that's a problem because you wanted 3 letters, but you only had 2 to start off with. So you cannot add more letters. That is never allowed. You just want to remove letters. So that's a problem. So it kind of gives me an intuition that, first of all, very important thing is, if in a string T, there is some letter and the occurrences of that letter is actually greater, if that occurrences of the letter is actually greater than the occurrences that they had. So this is like greater occurrences it had in the actual string which I started off with, then that's a problem. I know then I cannot add anything. That is straightforward or no case. But even better to this, what happens when we say that, like if we understand this greater case, then what is the main idea if you say it's not greater? Let's say I'll come back to the main example. Let's say you have 5. You want to remove the 2 letters. That's clear. You want to make this frequency go to 3. But assuming, let's say I'll take an example. Let's say a string S looked something like this. A, then let's say some letters, then A, then some letters A, then let's say some letter A. And then there's the string T in which you wanted some A's again. Not a problem. Now, there are 5 A's. You want to remove 2 A's. Which 2 should you remove? Very simple. It was given in the problem that I want to remove the first occurrence of the letter. So I would have actually simulated in my head and I would have said, okay, the first A removed, then the second A removed, and stop, because you wanted to remove 2 A's. So basically remove the first 2 A's from the string S. Yes, that makes sense. Or indirectly, if I want to save Ft number of, or frequency of frequency of that letter in the string T number of letters, then basically I would want to save the last Ft letters. I would want to remove the first Fs minus Ft letters in the string S. And this is actually the simulation. So that means I am preferring the last letters. Great. So how can I actually code this up so that I can simulate this and this works out well for me? What can I simply do is I can maybe run a for loop. And in that for loop, I can start processing everything I want to do from the back. That is from the last position of the string S. And then I can simply ask myself, okay, even before starting with the for loop, maybe I can create a frequency map of the string T. So I would know that what amount of letters do I want for everything. So I will have all the amount of letters I would have want, all the amount of letters I want for A letter, for B letter, for C letter, so on till Z letter. Then great, I'll stand in the last position and I'll ask, this position's letter is, let's say, some letter CH. Let's say currently the letter is CH. Do I think that the CH letter is something that is still relevant to me in terms of asking with respect to T string, as in, is it still present in the frequency map of T? I'll say, okay, if this CH letter has still a frequency occurring in this string T, then I know this letter has to be used. This is something I would want to use because after I would have simulated everything, this letter would have still retained itself. That makes sense. So I'll say, okay, string T, like let's say the frequency map, I'll create something like M map, and then I'll say, okay, inside this map dot find, were you able to find that this this letter, whatever this letter is, CH, is it present or not? If it is present actually, then I'll say, okay, great, utilize this letter, retain that letter, and I'll say remove one occurrence of this letter from the map, that is this frequency map of string T. What will that signify? That will signify that, okay, if I would have simulated the process, then this letter would have retained. I can basically just mark it off in the string. Great. Okay. Now, let's just say that you keep on moving, and let's say you read some more random position, and then standing at this position, let's say you felt that, okay, this letter has no frequency left over in the string t, which means this is still futile for me. I want to remove this letter. I would have actually, when I would have done the simulation, this would have been part of my moves where I would have removed this letter. So what should I do? Maybe just to, like, for my sake, just to make sure that I know I'm not taking this letter, maybe I'll mark it off with some other value besides a letter. Maybe I can mark it off. In my ideology, it would be perfect to mark it off, let's say, with a dot, because a dot would signify that this is a letter I would have in my simulation removed in those first occurrences moves. Great. And this is the ideology I can follow until I reach the very end or exhaust the string S, basically from coming from right to left. And after this, I know for sure that if I collect back, if I go in the string S and I see that, okay, if I collect all the letters, collect all places basically where you did not mark a dot, then that clubbed string should be equal to t. If it is equal to t, then fine, then you know your simulation worked. But if it's not equal to t, then you know never is this possible to actually create such a simulation. So this kind of brings us a very greedy based approach, right? Because of taking of this first occurrence. Let's actually take up a quick case, maybe the fourth case over here, which has an answer of yes, which we did not discuss previously, and simulate this whole idea. Okay, let's see what are we trying to do, what I'm trying to picture over here. So what I'll say is, this is my case, that is, this is the string S and this is the string T. So I'll first start off with by creating a frequency map of T, because it's basically necessary for me to know pre-hand what are the letters I wanted to keep, what are the occurrences of the letters I wanted to keep. So I'll make a frequency map for this. Basically that would give me something like A has a frequency 1, then D would have a frequency of 1, then I would have a frequency of 1, O would have a frequency of 2, N would have a frequency of 2, and I think T would have a frequency of 1. So I think 1 plus 1 plus 1, 2, and this is 4, and this is 8. So yeah, I have 8 letters. Great. Now what I'll do is, I'll start with the last position in the string S. Now I'll say, okay, I have the last letter, that is N. Do I want an N actually after I simulate everything? How do I check that? I have right now a frequency of N as 2, which is of course greater than 0, which means right now I do want that. Which would mean that indirectly, I want the last 2 occurrences of N to remain. Now because I'm standing at the very end, and I am looking at an N, and yes, I am standing right now with N equals to 2 frequency, which means I still have more N to go. So yes, I'll say I would utilize this letter, because this letter should be left off at the very end. I'll mark off with something like a tick or something. I'll just say, yes, don't bother it or don't hamper it. And then I'll just make my frequency of N go back to, from 2, it will go back to 1. This would exactly mean that I have marked off this letter, and I'm utilizing this letter because this is from the end. Now I'll go back to the next letter, O. I'll say, okay, does O have a frequency right now in the frequency map I created for T? Yes, it does, which means last, like in this case, because O is 2, so that must mean last 2 O's are required for me. So I'm right now standing at, because I started from the very end, I have first occurred a O, that should be retained. Great, make this frequency go to 1, and just don't make anything, like don't hamper this O, because this O has to be utilized. Now I'll go to an next letter, that is I. Okay, great. I is 1. So it should be utilized because I want 1 I from the back. Okay, you use this, mark this off as 0. Now, over to T. Do I want a T? Yes. Great. Mark this off as 0 and move further. Now over to A. Do I want this? Yes, of course I want this. Great. Mark this off as 0. Over to Z. Now, do I want a Z? I don't see a frequency of Z. That means indirectly the frequency of Z would have been 0. Oh no, don't use this. Mark this off in the string as something like a dot, because that would mean this is something I don't want. Okay, fine. Now let's move on. Move on to I. Now I also has a frequency turned to 0, which means I don't want I no longer, right? I have taken whatever number of I's I wanted from the back. Now I don't longer want more I's, so I'll just mark this off as dot again. And this is the manipulation that I'm doing. Same goes for L also. Like next time, this L will also become, this A will also actually become. So this is all dot, dot, and dot. Now I'll move on to this N. N is something I want. Yes, I want this N, so great. I'll mark this off as 0 and I don't hamper this N at all. Then I go to O. I do want this O, great. Mark this off as a frequency of 0. I, no, I don't want this I. T, do I want this T? No. Do I want a U? No. IE. Nothing like this is wanted by me till this whole idea. So I don't want this I also. Okay, great. So I'll mark everything as like a dot when I keep on moving, and then I finally land at D and I'll say, okay, I do want this D. So this will become 0 and I don't hamper this D. Now, actually, if you look in the string and I do the same thing, that is collect all the places where you actually had a letter or you don't have a dot basically, can you see you will receive something like a DONATION, which is actually donation. And can you say this is actually the string T? Yes, this is actually the string T. So can you see how smartly did we greedily simulate the whole process? Basically, this is nothing. If you now have understood the simulation of the case also, all we are trying to do is how smartly do we implement a logic where we are able to mark off the last, from the last location or from the back, the amount of letters I actually required to exist in the string T. If I'm able to do that and I'm able to make all the other letters not get utilized or basically mark off with a dot, which means they are never retained, I want to remove them, then at the very end, I just need to collect S, and that would mean that, okay, yes, the final string that I now receive is actually which should be equivalent to T. If it is, great, your simulation worked and you can report a yes. And if it is not T, then your simulation did not work and you will have to report a no. Okay, so very, very simple problem. Again, I'll repeat the small idea. You have to somehow, in a greedy manner, just implement a code or some logic which helps you mark off the last positions in the string S with terms of how much occurrences do you wanted of that letter in the string T. So to do that, just create a frequency map, utilize those number of occurrences of each and every letter from the back, keep on marking till you think it's utilized, and start marking it with a dot till now you think no longer do I want to utilize this or no longer I want to retain it. At the very end, just collect the string back and that should be your answer. If that is T, great. If that is not T, print a no. Okay, so very brute and an implementative based problem. Let us now actually look at the code part and see how can we do this thing. So I've taken a simple test variable, I input that, then I have the variables S and T inputted, then I just take up their sizes in two variables n and m, so that's clear to me. N is the size of the string S and nm is the size of the string T. Now I have a frequency map, so I could have used a map, but then I have a very simple way of creating another frequency map that is a vector based. I can have a 26 size in that, and then I can have everything starts off with 0. Then how do I mark off every frequency? It's a very simple trick that we use. I can iterate first of all in the string T, that is from 0 to less than m. Then T of I is actually the letter minus the ASCII value of capital A, which would actually turn up the whole value of Ti minus A as values that range from 0 to 25, which is the indexes that were possible in this vector. So then when I do a plus plus next to that, it will go to that every index and it will add on to that position. So it would indirectly mean that 0 index is capital A, 1 index is capital B, so on till 25 index is capital Z. This is a very trick-based solution that we are trying to do when it comes to frequency map creation. You can of course utilize a map. It's totally up to you when it comes to the implementation of this problem. Logic should be right. And then what do I do? This is the main idea. Iterate from the back because we want to greedily take the number of positions I do want in the string T in S. So I'll say, okay, from n minus 1 go to 0. And then if I feel that in the frequency map of T, this letter right now that is SI has a frequency greater than 0, then okay, fine. I would have used this, so I don't need to manipulate anything in the string S. So I'll just do a minus minus, good to go. Else, if it actually becomes after a point 0, then I know I will start marking S of I as a dot because that would mean this is something I am cross marking. This is something I don't want. I'm not returning this letter. And then I have a final string letter. Final string named string starts with empty string. I'll go to every position in the string S from the front now because I want to I would have actually simulated and I would have collected all the letters. And then if I feel this letter is not a dot, then I'll collect it and I'll add it to the final string. Then if this final string actually is equal to T, that means my simulation worked perfectly and I was yes able to create a string T, then I would print a yes. And if it did not work out this way, then I know never will it work out in any sort order because my logic is correct, so I will have to print a no. Okay, and this fetches you an AC on the sample cases also, and this will of course fetch you an AC on the platform. Okay, now what is the time complexity? So I have a simple loop over here that runs in M order, and then I have a simple constant sort of a logic over here to increment every value, so that's not a problem. Then I have an n loop over here, which is again simple, very simple, from n minus 1 to 0, and then this is pretty much constant, even this is pretty much constant. Then I have a final string iteration, this runs in again n, and then this again is constant. I'm just adding on letter at the very end. So overall, I can understand that, and yeah, I think this is something I missed. In the very final check, you will have to check like every letter to letter in the final string and the string t. So that would require something like m boundaries again, because that is the number of letters I'm almost marking. So basically, I am sort of making a time complexity solution in O of n plus m, roughly in order. Now, why n plus m? Because n is different, m might be different. Now, because n and m both are highest to highest in 30 order, I can just take this to be O of 30. That is the max case, because if both are 30, then also it's like 2 into 30, which is like 60. You can just remove that 2. Maybe you can report this even in a 60 order, that's not a big deal. But best case would be I report this as n plus m, which is somewhat a 30 order. And this is very fast. This is something like an O of s solution that we discussed, which is good to go because we wanted solutions that in less than 10 power 4 order, and we've created a solution that is very, very fast in terms of that part. So this is good to go. And like I can report this as O of n plus m, sort of something. Yeah. And now what about space? Now I am actually using some space when it comes to the string. So first of all, to actually take the string input and store it, it stores in a simple continuous based location. So that would require O of n plus m size again. And then I think I have the final string also, the vector also, that is of 26 size. So I can report this something like 26 size, and then some size for this final string also m. So roughly this is like O of n plus m again, which is like O of 30. So overall your time and space are well within my boundaries, and this will work, assuming of course my logic is right in this. Okay, so very brute solution, very implemented based solution. This problem was not at all hard. You just wanted to take the last few letters. How smartly do you mark them off is what was required in the problem. I showed you a way of marking them by taking this sort of a piece of logic. You can of course make some own logic of your own, and if you're able to do that, then you will definitely get an accepted solution on this problem. Okay, so that's all in this video. I hope you liked it. Thank you for watching.